Thank you so much for attending this session at the end of the day on the first day of Google Cloud Next. It really does mean a lot to Lucas and I, and as a sign of appreciation,
we need to clap, right?
We are giving you a proactive round of applause. So before we get started, we actually had a fun activity planned, and it works, with a larger audience, and it's contingent on a few things. So I'm going to ask a question to everyone. By a show of hands, how many of you would consider yourselves a security practitioner, security leader? Okay. How many of you would classify yourselves more on the development side of the house? Okay. The Lord. This is going to work still. Beautiful. You have made our day twice already, so thank you. We're really excited to be here to deliver this session on code to cloud visibility, the foundation of securing the new AI development lifecycle. My name is Salman Ladha. I'm on the product marketing team here at Wiz, focused on application security. And over the course of my career, I've had the privilege of working at companies that sit at the intersection of developer products and security solutions. So formerly, I was at Auth0, which subsequently turned into Okta. I was also at GitLab. I see one of my old coworkers in the audience here. And now I'm at Wiz, focused on our Wiz Code product. Now, it's not all professional. I always like to make these a little more personal. So a fun fact about me is that I'm Canadian. Are there any Canadians in the room? It's OK, right? That's fine. You guys like Canadians, right? Amazing. Sensitive. But as I mentioned, I'm joined by one of my favorite people today. Lucas, do you want to do an intro?
Yeah, absolutely. Thanks, Sam. I'm Lucas Gomes. I'm a senior technical marketing here at Wiz. I'm originally from Brazil, not Canada. Sorry, yeah, we're different countries. But I saw some soccer, Wizard here, yeah. So this is, grow up, playing soccer. No, I'm just kidding. I came from software engineering background, moved into product, right, and now working on the security space. And I see, you like soccer. This year, we're gonna have, World Cup here in the US. So it's time. Let's kick it off.
So we've got roughly 40 minutes in today's session. Lucas is going to be driving the demos. I'm going to be doing a lot of talking. Suffice it to say, he has the harder job. For any of you who have done live demos, you know the pressure and fun that comes with it. So as I mentioned, I realize it's the end of the day. So we want to do something a little different to kickstart the session, which is play a fun game. Okay? So what we're going to do is a quick elimination challenge. If you haven't done this type of game before, don't worry. Your objective is simple. You want to be the last person standing. Okay, so hopefully you cued in on that. Because my first ask of you, if you will indulge us, is if you're physically able, please stand up, like the real Slim Shady. Thank you. You're an amazing audience, honestly. So here are the rules of the game. Over the next few slides, I'm going to throw up a prompt on the screen. Your job is to simply answer yes or no to the questions that you're seeing. But remember, this is an elimination challenge, so there's a catch. If you answer yes to the question, you will sit down, and unfortunately, you're eliminated from the game. If you answer no, you stay standing, and you move on to the next round. Now, there is a catch. The last question flips these rules. I messed up making this presentation, but I want to call that out. But remember, you respond yes, you sit down. You respond no, you stay standing, and you move on. I always get asked this, are there prizes? Yeah, of course there are prizes. There are 3 things that you win. 1, thunderous applause from this amazing audience. 2, you get bragging rights for being a superstar when it comes to software security. And 3, if you come by the Wiz booth while Lucas and I are there, we will do our best to hook you up with swag. Sound good? I mean, even I couldn't get my hands on those. Let's kick things off with what I hope is a relatively easy question, all right? Do you enjoy when a fresh CVE drops on a Friday afternoon? Yes. It's landing perfectly. I'm glad no one sat down. Although if you did, judgment-free zone. What I love about our industry is we're all willing to learn, right, and share insights. Let's go on to something a little harder. Have you ever had a vulnerability sit unremediated because you didn't know who to assign it to? Interesting. All right. Let's move on to something a little more challenging. And I know this one's going to be fun because we have developers and security practitioners in the room. Have you ever disagreed with a teammate on a finding whether it was actually worth fixing? Yeah, I see the heads roll. Everyone was like, oh, darn, come on.
Come on.
Oh my gosh, wow. Okay, so I think I see one person in the back, George, and another. So remember, this last question is the hardest hurdle, and the rules flip. So if you answer yes to this next question, you stay standing. If you answer no, then you're eliminated, all right? Can you trace a vulnerability in prod back to the line of code that originally introduced it? Oh my gosh, are you sitting down? If you say yes, you stay standing. This is that weird question. So you're standing? Are you being honest, George? Well, as promised, at the back, what's your name? Mike. So everyone, let's give Mike and George a massive round of applause. You are software security superstars, all right? So why the fun game, right? I have the luxury in my role of interacting with individuals like you and our customers on a regular basis. And the reality is every single one of these slides that we beamed up on the screen points to a specific challenge I hear from them on a regular basis. The situation is with AI, all of these have been dialed up to 11. We're creating more code, it's generating more risk, and we have less time to respond. Now, our position at Wiz is that code to cloud context is a critical foundation every development and security team will need if we're going to secure the AI-driven lifecycle. And so in this presentation, there are 3 key things that we want to cover. The first, I know we're all in this industry, but I don't want to assume knowledge. We're going to kick things off with the state of the market, right? And the key message here is AI has changed the game for developers and attackers, and guess what? Security is often stuck in the middle. From there, we're going to make the case for a new model on software security, one where exploitability is the primary signal for prioritization. And we're going to close looking at the proactive side of the house, how AI and context allows us to shift left and fulfill the promise that it initially had in the first place as a proactive means of risk reduction. Now, this is a presentation on Wiz, so I have to ask, how many of you know who Wiz is and what we do? All right, so part of respecting my audience is serving you. I didn't see everyone's hands go up, but I saw some of your hands go up. So I'm going to spend maybe 40 seconds on this slide. So Wiz, first and foremost, is a cloud security platform, right? We help businesses protect everything they build and run in cloud and AI environments. We're working with 50% of Fortune 100 companies, and the reason they like working with us is our approach to security is fundamentally different. If you think about security, it's traditionally had these siloed roles. AppSec is here, SecOps is here, cloud security is here, but we all are trying to accomplish the same thing, which is reduce risk in our environment. Wiz shifts that paradigm to turning it into a horizontal approach to security, so we all have shared visibility and insights into the risks in our environment. We have since expanded the platform right into SecOps with Wiz Defend and left with Wiz Code, helping application development teams and software security teams secure their applications at the pace of AI. That's where we're going to spend the bulk of our time today, because in order to understand the challenges in AppSec, we need to take stock of how development has changed. And the key punchline here, as I'm sure all of you know, is that we are way past the point of experimentation, right? AI is an active character in the development lifecycle, whether that's through the use of coding copilots, agents, or even MCP servers. You can see the numbers on the screen here. This is data that we have gleaned anonymizing tenant data from the Wiz platform, and it does tell that story of AI adoption is on the rise. Now, I always like to look for external validation also, and this was a data set that was making the rounds earlier this year. I'm sure some of you, especially in the development world, have seen it. What it's showing is the volume of code commits to GitHub repositories authored by Claude Code. Now, as of February, this number was roughly 4%. That translates to 135,000 public commits to GitHub repos. This article also goes on to project that by the end of the year, that number is scheduled to hit 20%, or roughly 675,000 monthly commits. This is just Claude Code. It's not looking at things like Gemini or other agentic tools. And while it's not that one-to-one comparison to the enterprise, because hopefully enterprise orgs are using private repos, not public ones, it does give you a sense of the scale of adoption of these AI tools. One more data point that I want to marinate you in, and it's a qualitative one. And this is the stuff that really sits with me because I like the stories more than the numbers, as hopefully you can tell. But this was an article featured on TechCrunch earlier this year, highlighting how some of the best engineering teams in the world are no longer coding, they are prompting, and they're orchestrating. So the article features the Spotify engineering team, and the reason it resonated with me is because they talk about an engineer who, on their way to work, is prompting an AI on their phone, describing what they want the feature to do, and by the time they get into the office, the PR has been created and they just need to review it. Like, we're literally living in the future, right? Spotify is not a startup. This is a publicly traded company. It's a platform used by millions of people around the world, and their developers are no longer coding. Now, speaking on behalf of Wiz, this is also true in our organization, and I'm sure it's also true for many of your organizations also. So how has AI changed development? This slide really captures the essence of it. The traditional SDLC was governed by human checkpoints, and while AI hasn't eliminated them, it has compressed everything in between. We are generating more code faster with less human involvement. Now, this is fantastic because it has done wonders for our ability to get to market faster. For those of you engineers in the room, I'm sure you can go from prompt, tab to idea in a matter of minutes, right? Companies can build on their differentiated value propositions faster. They can defend their market share. But this is a security conversation, so let's talk about the implications of this, because the use of AI in the SDLC also comes with a risk. Now, AI is widening the attack surface area and is being used for nefarious purposes. Let's start with something that we're all very familiar with, which is what you're seeing on the left-hand side of the screen here. CVEs, CWEs, misconfigurations, and secrets. These are traditional flaws in software development, but with AI, they are scaling exponentially. If the volume of code generation has gone up so much, we're also seeing the volume of insecure code increase with it. I think the most recent stat that I saw was that roughly 25% of AI-generated code goes against basic standards benchmarked against OWASP. Right? So this is the lived reality, and when and if these vulnerabilities do make their way into prod, the mean time to exploit has compressed so much. We're not measuring it in hours or days, it's minutes and even seconds. So that's one side of the equation. The other side of the equation is we're seeing a novel wave of software supply chain attacks actively targeting developer identities and the systems involved in building software. So this started all the way back with things like Shai-Hulud, we saw Trivy, LiteLM, and I think even today there was one that recently got published. Right? Threat actors are not just targeting the source code, they're actively targeting the systems involved building software. And in this world, AI is being used across the entire attack lifecycle to speed up reconnaissance, automate decision-making, and scale execution once that initial access is gained. Now, the implication of these two things, right, AI supercharging coding and AI also being used by threat actors, is pretty obvious, right? AppSec teams in particular are drowning. The previous ratio used to be for every 100 developers, there was one AppSec person. With agentic coding, this ratio is close to 1,000 to 1. Right? And it's a real challenge because balancing product innovation and security was always a core challenge. But like I mentioned in the intro, we have now reached the breaking point. When I talk to AppSec team members in particular, it's really interesting in the language and how they communicate, right? They are really having a hard time parsing out theoretical risks from genuine threats. So let's bring Act 1 to a close, having understood the state of the market. The situation is that development has changed and we're not going back. The complication is that AI is scaling traditional risks, it's introducing novel threats, and it's part of the course for the attacker's playbook. And finally, the implication on lean security teams is that they're drowning with a model that wasn't built for machine speed. Right? More code, more risk, faster attacks. So what's the solution? Let's kick off Act 2. As I mentioned in the intro, we believe that software security fundamentally needs a new operating model, right? One where that code to cloud context is the critical foundation, where we can identify code level flaws, but also how they're going to manifest in cloud environments. That context allows software security teams to ruthlessly prioritize the risks that are truly exploitable, not just theoretically reachable, in spite of the volume of code generation. This is that reactive side of the story. So what does the model look like? It boils down to 3 key steps. The first is detection, right? We all know this to be true. We're going to run our scanners. We're going to check for code weaknesses with SAST and open source dependencies that might have risk with vulnerabilities. This is the standard playbook that we still rely on. And it's often where a lot of AppSec programs begin and end, right? But as we've talked about with the volume of code generation, we cannot just rely on detection because it's going to create a list of theoretical issues. It's not sufficient to help us prioritize. So the second step is around correlation. Let's take these code risk signals and understand the cloud environment. Let's map it to the containers that they're going to be actually running in, determine whether or not the application endpoints of these applications are publicly exposed, and see what other assets they might have access to. So from here, this already provides a ton of additional context that can help us prioritize, but we're not done. Because in the world of AI, the best defense that we have in security is to actually use AI on ourselves to identify issues. And this is the third step, which is all around validation. So how can we take runtime signals or even adversarial testing to check the validity of whether or not these findings are truly exploitable? And then, of course, once we have all of these, we can then trace the issues back to the source and drive remediation in code. So this is what it looks like conceptually, right? You have all of these vulnerabilities in code on the left-hand side, hundreds, maybe thousands of them, which, OK, this is good, but we're going to add on those additional context signals. So we go from those hundreds of thousands of vulns, enrich it, and we have one validated attack path that the AppSec team can focus on prioritizing. Now, in the product, we refer to this as a whiz issue. It represents a toxic combination of risk that brings together those individual signals into this validated attack path. And of course, we have the context to assign it to the right owners to remediate them quickly. Now, we've talked about this conceptually. Let's actually dive into the product and see how this manifests in real time. And for the purposes of this demo, if we can switch over to the demo environment, we're going to use the React to Shell vulnerability as our example. How many of you remember React to Shell? Right? It was the critical remote code execution vulnerability impacting Next.js applications. So a few of us are in the security org. Let's say it is that Friday afternoon, and the React to Shell vulnerability drops. It was actually a Wednesday, but indulge me. And we know with full certainty that our development org is building applications with Next.js. Where do we go from here? So the first stop in the product is going to be the Threat Intel Center. So our research team is actively monitoring the threat landscape and posting advisories. Actually, there's the one that I was talking about that dropped today, the checkmarks kicks compromise. So, that happened like a few hours ago. What we're going to do is we're going to go ahead and search React to Shell. And there it is. So Lucas is going to go ahead and click into this vulnerability. And you can see that we're populating it with relevant information, like the details of the exploit. We have notes from our own security team. We include things like the packages that are affected, as well as the versions that we should consider upgrading to. A ton of context, right, that the security team has at their fingertips immediately. Now, where it gets really cool is you can see that tooltip at the top of the screen over here. Because Wiz is agentlessly connecting into your cloud and code environments, we can take this advisory and actually surface up relevant information, like whether or not you are actually impacted by this particular vulnerability. So we can see here, we have roughly 42 vulnerabilities that Wiz has detected pertaining to React to Shell in this environment. Yikes. It looks like it's going to be a very long weekend. But remember, right, it's not just about detection. We're going to layer on those additional code and cloud and runtime risk signals to bubble up into an issue. So let's go ahead and click into an issue, Lucas. We've got roughly 18 here, so already we've chiseled down the work. Let's go ahead and open one up. We'll pick a critical issue to understand why Wiz is escalating this for something that the teams need to prioritize. Now, I personally love the titles of the issues because in plain English, it's giving the security teams a lot of context into why this is a high critical attack. So here we have a validated exposure of an MCP server with critical vulnerabilities on a container with access to sensitive data affected by the React to Shell vulnerability. So already a ton of information, but we can also see this on the Wiz security graph. This is something that we've really become known for in the industry. We're built on a graph database, and so the way that we're able to visualize information is quite intuitive. And you can think of this as like the application logic of the attack path at play. So why was this an escalated threat? The first piece is we can see the original repository branch where the vulnerability was introduced. And if we click into it, we can see that there is a CISA-known exploit. So that's signal one coming from detection. Let's add those additional signals, though. The second thing we can see is this vulnerability is actually executing in a production environment, and this is validated by the Wiz runtime sensor. So again, we're enriching it. Let's add the third layer of context, which you can see down here. This Kubernetes container contains admin accounts, and there's actually sensitive PII that a threat actor could theoretically exploit. Not good. The final piece, as I mentioned earlier on with the validation component, is we know that this application endpoint is publicly exposed to the internet, and we have an attack surface management finding delivered to us by the Wiz Red agent. This is our AI attacker working on your behalf to exploit these issues. So these combinations, these four things, are why that initial code risk signal turned into a fully fledged, validated attack path that we prioritized. So quite clear, the next step here is remediation. And this is where a lot of programs can stall. When I talk to some customers, especially in the enterprise segment, they have very complex developer environments, and it can be difficult to trace the ownership of who to assign this issue to. Because we're plugged directly into the version control system, we can not only see the initial repository and the repo branch, but also the code author that originally introduced this in the first place. So you can see here, courtesy of the Wiz Green agent, which is our fixer agent across the platform, the first step is to assign this to OR. From there, we can see step two is to upgrade the Next.js version to 16.0.11. From here, AppSec can very quickly create a pull request and assign it to the relevant owner. But in an agentic world, we can actually interact directly with the organization's coding agent. So Lucas, why don't we send this to the coding agent that this organization is doing, and let's see what that looks like.
Let's fix that live. Let's see what happens.
So we're going to click the coding agent button. We're going to view this issue and see what happens in GitHub. Now, Lucas, you're the demo king, and you're actively working in the demo environment and GitHub. What's going on? What are we seeing on the screen here?
OK. As you could see, the agent, it generated an issue on the GitHub repository where our development team is working on. It provided a description of the issue based on the risks that the Green agent identified. And it provided a recommendation for fixing that issue. And as you can see, we have the cloud agent installed on a repo, and it started working on remediating that. So as you can see, we have an automated pipeline that will trigger that remediation access. And right now, the code agent is analyzing all the code baseline. It's analyzing the remediation that was provided by the Green agent, and it's working on it.
Amazing. So hopefully this is giving you a sense on how that code-to-cloud context can help security teams ruthlessly prioritize exploitable risks in their environment in the face of AI-generated code, right? This is that reactive side of the house, which I think is really important because it's all about that maturity curve, right? There might be some organizations that aren't ready for that full-on AI agent-first approach to AppSec. But this is where we pivot because that same code-to-cloud context that we talked about is also how we can help shift left, deliver on its original promise. So if we can switch back to the slides. Thank you. Like shift left is one of those topics that whenever I talk to security and development teams, always a contentious one. 50% usually love it, 50% are not fans of it. I think shift left was a great idea in theory, but it often struggled in execution, right? Reflecting on it, I think we put the burden on developers to just own security, right? We put these scanners in their pipelines and they were lighting up like Christmas trees, generating all these alerts, many of which were non-issues. They didn't have the context, and it created a level of trust and friction with the AppSec folks. On the security side, this was our answer to scaling our expertise, right? The beautiful thing is with AI, we have scale, and with context, we can address that trust issue. So how do we address this today with Wiz? So part of our launch announcements here at Google Cloud Next are that we have shipped Wiz native plugins for AI development tools. This is bringing that rich context that Wiz has directly into the tools development teams are using today, not just the ones they were using yesterday. And this is a critical thing. Now, the plugins themselves aren't necessarily the story, it's what they can unlock. So with hooks, what we can unlock is when an AI agent writes code, the moment it's created, Wiz is able to intercept and scan it to identify potential weaknesses. We're running our SAS scan, our secret detection, IAC, as well as software composition analysis scan to identify these code flaws before they're even committed to a repository. Right, so this is that proactive side of the house, where if the volume of code has gone up and we're seeing a lot of insecure code, let's shift the control plane of AppSec directly into the agent-first workflow. Now, any findings that are generated at this point are directly surfaced to a developer in their IDE, and we can also guide the remediation process with our green agent, which we talked about earlier in the demo. Now, with Wiz skills, we can actually help development teams burn down existing security debt in their organizations. Now, this is something that I get particularly excited about, especially right now in this moment. Because hands up, how many of you heard of Mythos? Right? It's all the rage right now. The Wiz security research team has done quite a bit of homework on this, and we're anticipating over the next 12 to 18 months, we're going to see a surge in CVEs, right? Because defenders now have access to these frontier models that are really advanced. They're going to find all these software flaws. It's amazing. But the reason I'm excited about it now is human-based remediation flows are simply not going to scale. Right? What we need is if we have machine speed detection, we need to combine it with machine speed remediation. And with Wiz skills, developers can pull all of the active critical issues in their Wiz tenant directly into their native IDEs. We can orchestrate the remediation using the green agent in partnership with their respective coding agent. It is so cool, and I seriously feel like we are living in the future. But talking about this stuff is one thing. Let's jump into the demo and actually see it in action once again. So for the purpose of this demo, if we can switch to the, thank you, folks. So in this demo instance, what we have is an AI native application, right? We call it DataBot. Lucas actually vibe coded it, and the purpose is to give our executive team 24/7, 365 access to insights on the business. So Lucas, why don't we ask DataBot for a health check summary from the data platform? You can see we prompt it, DataBot is querying its database, and it's going to list a whole bunch of information. Right? This is actually very common because when I talk to customers, it's not just the technical folks who are building these applications. We now have finance, HR, non-technical teams vibe coding applications like DataBot. But the concern is security may not be aware of them, and these 8 non-technical teams may not even be conscious of the potential risks applications like DataBot expose. So as you can see here, why don't we try to do a prompt injection on DataBot? Let's ask it for customer email addresses and other details. And unfortunately, DataBot is very kind, and it's forking over a whole bunch of this insight. So let's shift into the Wiz platform so we can show you how we're giving security teams complete visibility into AI applications, how we're arming developers with that code-to-cloud context for remediation at scale, and how we're bringing application security earlier into the AI native workflow. Lucas, over to you.
Okay, thanks, Saul. So let me start, for those who are not completely familiar with Wiz, I'm just loaded the AI secured lens, so it brings functionality for AI specialized folks, so you can visualize all issues, all resources that you have that are related to the AI context. So here it's where secure teams can visualize all their AI footprint, right? It goes into the inventory, and you can visualize all the cloud services that you have, and that includes agents, models, guardrails, the MCP servers, pipelines, data stores, and so on and so forth, right? The list here is growing, right? We are adding more capabilities. You can also visualize code-related assets, right? So your code agents, right? They're running on the developer's machine or the ones that are deploying on your pipeline on your repos. So let me go into the agents tab. So we need to look up for Databot. As you can see here, we can visualize different agents for different platforms. As you know, agents, AI applications, they are quite, hard. They have very complex architecture. You might have agents running on different cloud providers or in SaaS platforms. So we can surface all of those here to our AI inventory. So that helps, with the shadow AI problem. Okay, let me look up for Databot app. All right, I find the first one here. I have it deployed across different environments. So, okay, this is Wiz. What Wiz can identify here? Some things that I wanted to call out. First, my AI agent, there is a risk in my control that was identified by Wiz. It also surfaced some capabilities of my AI agent, like, it has read capability, so it can read, data, code, has write capability, and can also execute code. It provides a description of my AI agent here, so what it's doing, what it's understanding, right, connecting to database issues. And through code-to-cloud correlation, it can also provide visibility into the code, so what developers wrote, so it can actually verify that it's an AI application because you have, all the system prompting, all the agents, the tools that are getting called by this agentic application. So that's the code that's matter. And as you can see here, you can also visualize through the AI workload explainer. So we have an AI capability, an engine that will analyze that code and will surface what is the architecture behind that agent. So we normalize that, and as you can see, we have a full visibility of the connections of this agent. So we can see it's an agent, has some tools, it's connected to a model, there is a virtual machine where it was deployed as agent, and you have a service account associated with that machine that has access to a database and also a bucket with some personal data. There's some additional information here, like where it's running, and more details around the AI tools capabilities, okay? So let's shift into issues. So as we saw, there are some issues related to this agent. Let me choose one here. Similar to what Saul showed, it explains what is this issue, right? It's an externally exposed AI agent with authentication bypass, vulnerability, exposes sensitive data. As you can see through the graph, you can see the endpoint, the vulnerability validated through the AI agent, exploitable from outside in. You can see that there is a path that leads to access to a sensitive data because they're a service account with overprivilege. And then we have the remediation tab, similar to what we saw on the other issue, where you have the full remediation tab, the remediation steps where we can remediate directly here and send to the code agent, or we can shift left and we can also remediate that in the code, okay? So shifting left here, I want to just talk about the new capabilities that we just introduced, right? So we have the new AI plugin that introduces new capabilities. We have an AI skill called with remediate, and this is where I want to focus right now. So this plugin, it gives the code agent secured skills, right? So you can grab the same context that is available on Wiz for your secured team, also available at the hands of the developer directly to the IDE. So I'm not going to go through all of them. I run that before, so I know we have some limited time here. So this is what is happening, right? So our AI skill, it's using the Wiz MCP server to pull all that information, right? So you can set up the MCP server here directly, and it's going to connect to Wiz. We identify what is the repository connected to this workspace. It's going to list all the issues. It's going to create the attack path based on the security graph, the same as we saw on the Wiz dashboard. It will generate the list of vulnerabilities with all the findings, and we will enrich all that information with the data from the green agent and also our blue agent, which is our SecOps agent. And we'll generate you get the issue from the security graph to generate the full attack path. What is more important here, it's going to build a secure report for your developer. So as you can see, it's the same issue that we saw. It explains all the critical risks, what exactly is happening with the secure risk, and also generate the full attack path, right? You can see the application exposed through the internet. There's an authentication bypass on one specific endpoint, the tools that executed, and it generates at the end a summary with the remediation steps.
Lucas, if you can scroll back up to the security report, like one thing that I think is really important to highlight here is if you can go to the security report for a second, higher up. Right, this is the exact same context that the security teams have in Wiz, which is their platform, now brought into the developer's native workflow. Like this is actually incredible because I feel like this is something that I haven't seen before. I'm very biased being here at Wiz, but it does imbue that same context between these two teams that historically live in different tools, right? We're bringing it all into the same, or the existing tools that they're using.
Okay, as you can see, the skill that I ran first, I was prompted if I wanted to proceed, so there's some human in the loop with some controls for the developer, what I wanted to do, I can apply those fixes, and now it's starting applying those fixes with the agentic flow direct on my IDE. I did it before again, so yeah. As you can see here, this is what the code agent, how it remediates. So based on the insights from the green agent, all the fixes that were recommended by the green agent. So it fixed it, we have some Terraform code here that was changing the permissions of and the role of the user that we are having our application. It also changed, some network settings, the scopes for the application. There was a vulnerability that was allowing the authentication bypass, so it fixed the library on that. Changed also some SQL queries to enforce some guardrails, and also on the prompt itself. Okay, so now that means the developer could look all the different in the code, can review that code, and can decide what is the next action. Can iterate with the agent, right, using natural language prompts, or can go ahead and commit the code. And that's another part that I want to show, right? So when you commit the code, Wiz now is triggering a pre-commit hook that is automatically fired to the IDE, and it can execute the Wiz CLI behind the scenes, and we'll start scanning your code. And as you can see here, it found 2 secrets, right, and 6 SAS findings here. They are all pre-existing, vulnerabilities and findings on my code base. It was not introduced, right, through the remediation flow. And more important, all of those were blocked by our pre-commit hook, right? So with that, we block and we avoid, those vulnerabilities to land into our pipeline, into our GitHub repo, right? All through an automated agentic flow, completed, controlled, and secure on your lifecycle. With that, it's back to you, Sam.
Back to me. Can we go back to the slides? All right. So we have covered a ton of ground, and we have just a few more minutes. We are at the end of the session. So 3 things that I hope that you walk away with. First, at the top, we covered the market context, right? AI has changed development. It's changed how attackers operate. It means our traditional approaches to software security also have to evolve. Part of that evolution means going beyond just looking at code risk signals in isolation. Right? With the volume of code that's being generated, we can no longer just rely on standard detection. We have to enrich it with additional signals from cloud, runtime, and even adversarial testing so that we can prioritize exploitable risks, not just theoretically reachable risks. And finally, on the proactive side of the house, right, all of this context and AI unlocks the capacity to shift left and fulfill the promise that it originally had by moving the control plane of application security directly into the agent loop. All of this is powered by that code to cloud context. It cannot scale because it doesn't have the right context. If there's anything you walk away with after this 45-minute session, it's this. Right? Code to cloud context is not just a feature, it is the foundation that security and development teams have to have if we're going to secure AI-driven development. So if you're interested in learning more, feel free to stop by the Wiz booth. We're at 2523, and you can also check out the Wiz blog. To the winners of the game, remember, swing by tomorrow. I will be there, I think, in the afternoon, and Lucas will be there at some point. Thank you again for being such an amazing audience at the end of the day, and we hope you appreciated this session. Thank you.
Thank you.